Hi, everybody. It's Miss Rose. We have talked a little bit about how to do some transformations of points. We have translated them, which was a fancy word for shifting. We have reflected them. Now let's learn about rotation, which is probably the trickiest out of the transformations. We sometimes rotate things in a clockwise direction, and we sometimes rotate things in a counterclockwise direction. So picture the hands on a clock. The direction in which the hands typically move, that's the clockwise direction. If you want to rotate something in the opposite direction, that's counterclockwise. So that's going to be really important to picture when we're talking about rotating points. And then every time you rotate something, you need to know what point you're rotating around. So I'm going to call that point the center of rotation. Let's try a few examples and you'll see what I mean. So here is example number 1. It says rotate point A 90 degrees counterclockwise about the origin. So the origin is going to be our center of rotation. That's this 0, 0 point. And then we want to make sure that we're rotating counterclockwise, so the opposite direction of how hands on a clock rotate. So how do we rotate that point 90 degrees? Well, 90 degrees will move point A from being on the horizontal axis to being on the vertical axis. So if point A is at 5, 0, it's 5 away from my center of rotation. I'm just going to count up 5. And that will be my new point. The new point's called an image. And instead of calling it A again, in order to differentiate between the point that we started with and the point that we got after we rotated, we go A prime. If you notice, if I were to draw a line segment between the origin and A and the origin of my new point, you can see the 90-degree angle that you get when you rotate 90 degrees. All right, let's try another one. Let's try point B. What is the center of rotation this time? It's the origin again. This time, though, we're going to rotate B 90 degrees clockwise. So the direction that a clock goes. But we're going to do same idea. So point B is 4 down on the y-axis. So we're going to go 4 over on the x-axis and call that new image B prime. And in order to check and make sure that that looks right, I'm going to look for my 90-degree angle that I get from B to the center of rotation to B prime. All right, next problem is a similar one, but it's not 90 degrees anymore. It's rotate point C clockwise about the origin again. So center of rotation is my origin again. Once again, I want to go clockwise. This time C is up 7 units on the y-axis, so I want to go 7 units again. But here's the deal this time. If I go over to here, that's only 90 degrees, so I need to keep going around clockwise. So 90 degrees, if I keep going, I'll get to 180 degrees. If I keep going, 180 plus 90 is the 270 that I was looking for. So that point there is my C prime at -7, 0. Let's try something a little bit different. Number 4 says rotate point F 90 degrees clockwise about the origin. So why is this one different? The center of rotation still the origin. That feels like what we did before. Well, the previous 3 problems, I purposely gave you a point on the X or Y axis, which makes it much easier to picture how to rotate at 90 degrees. It's a lot harder to picture what it looks like to rotate F 90 degrees. Where does it go? It's not going to go on the axis. So in order to figure this out, we're actually going to use slope. So I am going to count my rise up 5 and my run over 2. The slope from the origin to point F. Here is the new, interesting, tricky part. We will learn more about this and why it works later this year. But in order to find the new point that we get from a 90-degree rotation, we don't want to use the same slope from our center of rotation. We want to take our slope and find what is called the opposite reciprocal slope. Opposite means I'm going to go from positive to negative. Reciprocal means I'm going to take that fraction and I'm going to flip it upside down. So here's what I do. I want to make sure to go in the right direction, clockwise. So I kind of like to draw that arrow in to see where I'm going. I'm going to start at my center of rotation, my origin, and I'm going to use my new slope and go down to over 5. And that is where my new f prime is going to be. That might seem like, I don't see it. How is that a 90-degree rotation? Do what we did in the last example. If you draw the segment from the origin to f and from the origin to f prime, you'll see that 90-degree angle. If it doesn't look like 90 degrees, then you probably did something wrong. Let's try one more example. Rotate point G 90 degrees counterclockwise about the point 4,3. What's different about this one? This is the only problem where we haven't used the origin as the center of rotation. We need to use the point 4,3 as our center of rotation. We're going to rotate G counterclockwise. That's this way. So let's do what we did in the last problem. Let's find the slope from the center of rotation to G. The rise is down 2 and the run is over 3. And then we're going to do our opposite reciprocal. So it's going to go from negative to positive and then it's going to flip upside down. Instead of 2 over 3, it's going to be 3 over 2. So what we do is we start at our center of rotation, always start there, and go up 1, 2, 3 over 2. And that's my new point, G. I'm going to draw those segments in again just to make sure that it looks like a 90-degree angle. And it does. So that's a little mini lesson on rotations. We're going to do some practice and let me know what questions you have.